So let's look at some different example problems for determining supplementary, complementary, and vertical angles. So we need to find the relationship between angle B and angle A. So angle A is in blue and angle B is in green. And what we can notice is that when you add these two angles together, when we're talking about both of them combined, that we have the angle of a line. So APB, this is just a line. So angle A plus angle B forms this 180-degree angle, since we know that the angle of a line is just 180. So if angle B and angle A add up to 180, we have a word for that. That is called a supplementary angle. And just so we can get used to some of the different vocabulary, when you have supplementary angles, a lot of times you also have vertical angles. So remember, vertical angles are when you have two intersecting lines, and we're talking about the angles that are opposite. So angle B would also be equal to this angle APC. So that is also equivalent to angle B. And likewise, the angle that's opposite angle A, this CPB, this has the same magnitude. It's the same amount of degrees for this bigger angle here. So supplementary and vertical angles often show up together, not always, but it is good to practice a little bit of the vocabulary here. So let's do some more examples. And for this one, we need to know the relationship between angle A and angle B. So notice we have two lines that intersect each other right here. And these are the two angles that are opposite each other. So just like in the last example, we talked about it where opposite angles, these are vertical angles. That's the word we use for two opposite angles with intersecting lines. And remember, we also know that vertical angles are equal to each other. And one of the key points when studying geometry is that you don't want to rely on the picture, but the picture can often give you a clue to what might be true. And you can visually see it looks like angle A and angle B are equal to each other. Just like if we look at the angles next to these. So maybe we call this angle C. This would have a vertical angle right here. This is also angle C, and notice that angle A and C are supplementary. They form the angle of a line. And angle B and angle C are supplementary. They also form the angle of a line. Since, like I mentioned, vertical angles and supplementary angles often show up together. So let's do one final example. And with this example, we need to know the relationship between angles A and B. So this one's a little bit tricky since we're not told really anything about the combination of these two. This visually doesn't look like a right angle, and it doesn't look like the angle of a line. In fact, we know it's not the angle of a line because that would be also including this DAC here, and that's not part of this. So they're not supplementary because they're not adding up to the angle of a line. They're not opposite each other because we don't have the extension here going on. So maybe the vertical angle for B would be right here if this continued on, and the vertical angle for A would be right there if that continued on, but it doesn't. So we're not talking about vertical angles either. So we can cancel that out. And we're not told any information about whether or not these add up to 90 degrees. For one, it doesn't look like they do. It looks like a 90-degree angle would actually be less than angle A. But again, we don't want to rely on the picture. We want to just rely on what we're told. And we're not explicitly told that these add up to 90 degrees or that we have any right angles here. So we can't assume that they're complementary either. So this is a case where it's actually none of the above. These don't have any particular relationship to each other. They're just two angles that are next to each other or adjacent angles.